Okay. So y equal to fx passes through this guy, okay, such that the phi intercept of the normal at any point. So what's the normal at any point? First of all, it would be y minus y naught upon x minus x naught equal to negative 1 upon m. And we are talking about the y intercept of that. So for that, this is 0. Sorry, not this. This is 0. So just have y equal to y naught plus x naught upon m. Yeah, this would be the y intercept. Instead of writing naught, I will just write y plus x upon m. So these y and x are of that p, okay, and it's equal to the distance. So the mod of this thing, of course, I believe. Or is this the positive quantity itself? Well, in either case, it doesn't matter because we're going to square this. Square root of x squared plus y squared. Okay, let's square this. So just the y squared plus x squared upon m squared plus 2yx upon m equal to x squared plus y squared, right? What does this give us? This cancels. Yeah, you know what, maybe it's not the best to do it like this. Let's not square this. And say that instead we will just say that y plus x upon m. So you know what, let's just say that it's positive. Just talk about the positive solution. So it's going to be plus x squared plus y squared, like that. So x upon m equal to square root of x squared plus y squared minus y. So just have, well, this can be written in a different way, I guess. This can be written as, well, if I multiply by its conjugate, that is, it's going to be written as x squared upon square root of x squared plus y. I mean, why am I doing this? Because I want this m in the denominator and stuff. So cancels, cool. So just got m equal to this function. Okay, so notice how this looks very much homogeneous. So maybe we can say like y equal to kx, and let's see what happens after doing that. So m, that's just dy by dx. That's going to turn out to be k plus x k dash equal to, so this would be square root of 1 plus k squared plus k, I guess. Yeah, and this cancels. Just have k dash upon 1 square root of 1 plus k squared equal to 1 upon x. Let's integrate this thing on both sides. So we know how to integrate these kind of functions, right? 1 upon square root of quadratic. This would just be natural log of k plus square root of 1 plus k squared. And notice that this is positive. Well, it doesn't matter. Equal to, this would just be natural log of x. So natural log of x plus c, right? So yeah, this would be k plus square root of 1 plus k squared equal to kx for some, okay, this I just used it once again, so that's not good. Say capital Ax for some value of a. So they are saying that negative square root 3 comma 1 satisfies this thing, right? Because it sits on this curve. Maybe I should first of all write it like this: y upon x plus square root of x squared plus y squared upon x, right? So this gets cancelled. Cool. And what they are saying is that negative square root 3 comma 1 sits on this. So 1 plus square root of it's going to be 3 plus 1, so it's going to be 2. A times 3, of course. So a is 1. So just have y plus square root of x squared plus y squared equal to x squared. Send that over there. So it's going to be x squared plus y squared equal to squaring this, right? Squaring this, you just get, oh, first of all, you just have x squared bigger than y. That's another important thing. Of course, it could also be like negative and stuff over there, but like, let's not talk about this. Yeah, I'll just talk about it like that. So this will be x power 4. Skip this thing. For appropriate values, it's appropriate. Okay, cool. Right, x power 4 minus 2x squared y plus y squared. Some stuff cancels, some more stuff cancels. So you just have x squared equal to 2y plus 1, right? Yeah, a parabola with negative 1 by 2, right? So like 0 comma negative 1 by 2 is the vertex. So this is how it is looking like. Okay, cool. And this is when you have x squared bigger than 2y. No, not 2y. What was the thing? Yeah, x squared bigger than y. At that point you can do this, right? Yeah, because that should be positive square root over there. Okay, cool. So questions are, which one of the following statements is correct? F of x has exactly 2 points of well, it doesn't have a point of inflection. So yeah, this is incorrect. It has maxima, but no, it has a minima, but no maxima. The equation f of x equal to, wait. F of x. We don't want a curve. We want, well, fine, it's a curve. It's okay. So it is y equal to f of x. Right, just make this thing into different formats, like y equal to x square minus 1 upon 2. Fine. So yes, it only has a minima, it doesn't have a maxima. The equation f of x equal to minus 2 has two distinct real solutions. You just want x squared minus 1 upon 2 equal to minus 2. So x squared minus 1 equal to minus 4. This doesn't look good. I don't think so. Inclination of the tangent line drawn to f of x at 1 comma 0 is tan inverse 1. Well, 1 comma 0, of course 1 comma 0 it sits in this, and it also satisfies this condition. Okay, and we want the inclination of the tangent line drawn at 1 comma 0, right, somewhere over there. Y dash would just be x, that's it. So at that point it's going to be 1, right? The slope is going to be 1, so it's, yes, it's tan inverse of 1. This is the correct thing. Okay, it's supposed to be like that. So the first one is D. The area enclosed by a curve and the coordinate axis is, so this and, right? Okay, so I think they're trying to tell us, like, ask what's this area, isn't it? Or are they trying to talk about this area? I don't know. Curve C and the coordinate axis, I guess it's this area. Okay, fine. So integration from 0 to 1, what's this going to be? Isn't that what they're asking? So this will be x cubed by 3 minus x, all that half, from 0 to 1. So it's half of 1/3 minus 1. Actually get mod of that, of course. So half of is going to be 1 minus 1 by 3. So it's like 2 by 3. So it's 1 by 3. I guess so. I mean, why didn't they take this area and all other things, like, yeah, whatever. The shortest distance between the curve C and the circle. Okay, so it's like x squared plus y minus 1 squared equal to 1. So it's centered at 0 comma 1 and it has a radius 1, something like that. So what's the shortest distance? Okay, well, what's the shortest distance of this point from all of these points? Of course, the one where this is like normal over there. Cool. Yeah, and hey, do we know something about this parabola? Y squared equal to, okay, you know what, x squared equal to 2y plus 1. This is much better. Let's try to do it like this, that instead of thinking about it in coordinate geometry, we'll just think about geometry. Like, this is a parabola, x squared equal to 2y plus 1. This is the distance 1, and this complete thing, what's this distance? Yeah, that's a problematic thing. What's this distance? When x is 0, y just becomes negative 1 by 2. So this would be 1 by 2. So it's 3 by 2, right? So this parabola, it has 3 by 2 distance, and then there's this point with circle on it. Okay, it is y squared equal to 2x. I mean, like this curve. Okay, y squared equal to 2x. So it's a value is just 1 by 2, so its focus is at 1 by 2, of course. Hey, that's nice. It's at 1 by 2. This is where the x-axis, like previous x-axis, was. Okay, and we just want the shortest distance like this. So the, yeah, yes, but this is not a proper point, like whatever. Fine, we'll just think about the normal in that case. It's like y equal to negative tx plus 280 plus 80 cubed. Our a value is 1 by 2, so y equal to negative tx plus well, 2a is 1, so t plus 1 by 2t cubed. Alright, and our y value is 0, so 0 equal to our x value in this case is 1 by 2 plus like 1, of course, like 3 by 2, isn't it? Yeah, that would be correct. So negative 3 by 2 t plus half t squared, sorry, t cubed. Cool, so it's like multiply by 2 and divide by t, so 0 equal to negative 3 plus 2 plus t squared equal to plus minus 1. I'll just take 1 over there. If it's 1, then we know what this point is. This point is just 80 squared, which is half, and 280, which would be 1. So from half comma 1 you have this guy. Okay, and what is this thing? I mean, like, t could be 0 or it could be this thing. This point we know is just 3 by 2 comma 0, right? So what's this distance? Square root of 1 squared plus 1 squared, which would be 2. And what's this distance? Sorry, it should be square root 2. And this distance is just 3 by 2, we know that. Which of them is bigger? Is 3 by 2 bigger or this? I think 3 by 2 is bigger than square root 2, right? Because 9 is bigger than 8, of course. So that just means that this is the shorter distance. So square root 2 minus 1, that will be the shortest distance. Okay, this is getting messed up. Let f be a real value. Wait a second. Let f be a real value differentiable function satisfying this property. Hey, I've seen this property a lot. Yeah, but not with these things. Okay, that's weird. For all x and y, and f of 1 be equal to 1. Alright, so how would you solve this? F of x plus f of y minus xy. So that's xy. Come on, think about it. Well, if this is true for all real values of x and y, we could exploit some kind of special case and get this done. But what? Well, let's say what happens at when y is, yeah, when y is x, right? So it's like f of 2x equal to f of x plus f of x minus x squared minus 1. So it's really just f of 2x equal to f of 2x minus x squared minus 1. Okay, this is weird. This is very weird. Come on, think about it. We just really want to convert this into something that's very doable, but I don't know how to do it. Now, what about f of 2x? How do we deal with that? Like, instead of yeah, we could be doing this, but that's just stupid. What happens if I put y equal to 0? Well, that we just get what? F of x equal to f of x minus 1. This is definitely not true. Of course, it doesn't make sense. Just, you said that it's true for, oh yeah, but there's more than that. It's also having plus f of 0. So we straight away know that f of 0 is 1. and f of 1 is also 1. Huh, that's weird. Okay, cool. Now what? I don't know. Let's try to put y equal to negative x. So we just have f of 0 equal to f of x plus f of negative x minus, okay, so plus x squared minus 1. We know this is just 1, so f of x minus x. But this is not so. Yeah, what am I doing with this? I am not supposed to do this. Come on, what can we do to make something happen? Minus 1. Like, what would happen if I put that over there? Okay, that could be useful. That could be real useful, but xy, that's not gonna work. This is definitely symmetric, so whatever function we get, that's gonna be symmetric in x and y probably. This looks like a Cauchy equation thing, but you got these terms over there which are not good. But still, let's try to apply that logic. So like f of nk plus k is just f of nk plus f of k minus what is this, xy, so it will be nk times k, so nk squared minus 1. Cool. Right, now what? Hey, first of all, let's do some kind of transformation to clear things out. Let's say that g of x is f of x plus y minus 1. So we just have g of x plus y equal to g of x plus g of y plus, sorry, minus xy. Yeah, that's cool. Now what? Come on, think. What would happen if I put natural log and stuff over there? And that would not be good. Okay, that would definitely not be good. Okay, x plus y squared, like g of x plus y squared, something like that. It'd be like half of x plus y squared. That would be g of x plus g of y. Adding half x plus y squared on both sides, I just get plus half of x squared plus 2xy plus y squared minus xy. So this term gets cancelled. That was my yeah. So you know what, let's do this. I'll just set, instead of doing this substitution, I'll say g of x is f of x minus 1 plus x plus y upon 2, sorry, x plus y squared upon 2. I mean, like, okay, I should just say x squared upon 2. Yeah, that's better. Okay, so what that tells us is that g of x plus y equal to g of x plus g of y, of course. Like, think about it, just doing this substitution, what do you have? F of x equal to 1 minus x squared by 2 plus g of x. So f of x plus y plus 1 minus x plus y squared upon 2 equal to, so now instead of f of x, I'll just put this complete thing, g of x plus 1 minus x squared by 2. Similarly, g of x, so g of y plus 1 minus y squared by 2. Okay, minus xy minus 1, this gets cancelled. Cool. This also gets cancelled, and this is definitely true, because, like, yeah, this expands to this complete thing, so this also gets cancelled. So yeah, it's just this thing. So you have this equation, and that's it, essentially the Cauchy thing. So you know, like, g of x is just kx. That's right. So yeah, what do we have? We put g of x as, where did it go? F of x minus 1 plus x squared by 2. It is basically kx. k for some constant k. So this just tells that f of x is negative x squared by 2 plus kx plus 1. Cool, that was nice. Okay, and now what? Now let's solve the question. F of 1 is 1, that's nice. So 1 is negative 1 upon 2 plus k plus 1. So 1 is 1 by 2 plus k equal to 1 by 2. K equal to 1 by 2. So you just have f of x equal to negative x squared by 2 plus 1 by 2x, yeah, because k equals to 1 by 2, and plus 1, right? Yes, that's the whole thing. Cool. So the equation of the normal to graph of this guy at point y, where y equal to f of x cuts the y-axis is what? Okay, when it cuts the y-axis, that's when its x is 0. So like this would be 0 comma 1, that's the point, and we want the equation of the normal at that point. Of course we can do this. So just take a derivative first of all, like m would just be minus x plus 1 by 2. So the slope would be minus 1 plus 1 by 2, which would be negative 1 by 2. So negative 1 by 2, like, okay, cool. 2 would be the slope of normal. So y minus 1 upon, oh no, sorry, 1 by 2 would be the slope, of course. So then minus 2 would be the slope of the tangent, sorry, the normal. Okay, let's just do this thing. Y equal to negative 2x plus 1, that's the thing, or like 2x plus y minus 1 equal to 0. So it should be B. Area enclosed by the curve in the first quadrant is in the first quadrant. Okay, what's the thing once again? Okay, this guy, minus x squared by 2 plus x by 2 plus 1. First of all, when is it 0? When it is 0, you just have x squared minus x minus 2 equal to 0. So like x minus 2 into x plus 1 equal to 0. So either x is minus 1, which is not good, it's not in first quadrant, or x is 2. So it's integration from 0 to 2 of this function, x squared by 2 minus x squared by 2 plus x by 2 plus 1, okay, dx. So this would be negative x cubed by 6, I guess. Okay, yeah, yes, and in this case x cubed is like 8, okay, plus x squared by 4. So 2 squared like 4 upon 4 cancels, just 1, plus x, which is 2 in this case. So this is negative 4 by 3 plus 3. So it's 9 minus 4, which is 5 upon 3. That's right. Next, let T be a triangle with vertices 0, 0. Let's draw this. 0, 0, 0, c squared, which would be this. Okay, this is c squared, and c, c squared. Huh, that's weird. So like that. Okay, and let R be a region between y equal to cx and y equal to x squared. Okay, so this we know it passes through y equal to x squared, and y equal to cx, that would be a line which also passes through this point. Cool. So T is the region between this, like this is the region that we're talking about. Okay, then area, that was okay, cool, fine. The area is just integration of cx minus x squared, and it's going from 0 to, wait, let T be a R be the region, of course, sorry. Yeah, so this is the triangle that they're talking about. Let's draw this neat and clean once again. This is our y equal to x squared thing. At c, this is c squared. Then you got 0, c squared over there. Then you want to take this triangle, right? Okay, so this is our triangle T. What did they say? R is the region between this is R, this is R, this is T. Okay, so area of R, fine, just integration of cx minus x squared from 0 to c dx. Just wait a second. Okay, let's continue. So this integration, cx squared by 2 minus x cubed by 3, well, it should just be like that, like c times c squared, c cubed by 2 minus c cubed by 3, which will be c cubed by 6. Cool. So that's the area. Limit as c tends to 0. Okay, what is area of this triangle? This is c and this is c squared, so it should just be half of c cubed, isn't it? So area of triangle, which is half c cubed upon area of this R region, that's that's 1/6 c cubed, that's going to be 3. So even this limit is 3. Yes, this is correct. This is multiple correct, right? Okay, area of R, this is not correct. No. Okay, next. Okay, f of x comma y equal to so much. Okay, fine, this is not on that paragraph. Is a homogeneous function of degree 0. Okay, this is not homogeneous, I guess. I mean, yeah, it doesn't look, but okay, fine. I mean, like, it's y upon x over there, so might as well say that. Of degree, degree is not defined in this case because these are like transcendental functions and we cannot say anything about degree, so this doesn't look true. Next, this function is a homogeneous function, differential equation of degree 1. Looks like dy by dx over there, and then you got maybe, I mean, like, think about it, it's natural log of y upon x plus y squared upon x squared sine inverse of y upon x. Yeah, it looks homogeneous. Okay, once again, the degree is not defined because of this problem. Yeah, but maybe we could somehow make this into something that is homogeneous. Well, I don't think its degree is 1. Its degree would be more than that, of course, when you differentiate this thing, right? Effect is order is gonna increase and stuff. So let's try to think about it. It's more like dy by dx. Yeah, whatever, skip it. I really want to just skip this because even if you did differentiate, it would still be transcendental, so no thanks, we won't do it. F of xy equal to this function is not homogeneous function. Yeah, it's not homogeneous. What's the big deal with that? X squared plus, oh yeah, this is the correct thing in that case, so C is correct. Yeah, it's not a homogeneous function. X squared plus y squared dx minus all that stuff is a homogeneous differential equation divided by x squared, which is 1 plus y squared by x squared and dx as well, so minus. No, this is not a homogeneous differential. So C is correct, this is not correct. Yeah, that's how it is. Next, suppose f is defined from real to this thing as f of x equal to this thing, okay, where I is the set of real number. Fine, then the statement which does not hold good is many 1 to k many 1 on 2. Well, is it a many 1? F of x equal to x squared minus 1 upon x squared. This thing is probably always defined, so we can write it as 1 minus 2 upon x squared plus 1. So f of a being equal to f of b just means that 2 upon a squared plus 1 equal to 2 upon b squared plus 1, which gives a squared equal to b squared. So no, it's not a 1 to 1 function, it's a many to 1 function. And is it on 2? Well, is it on 2? This thing is always bigger than 1, that's what we know for sure. So what is the maximum value of this complete thing? Yeah, it's just going to be 2. So it's this complete thing's minimum value is -1. So it's not, actually it is in fact, wait, and what is its, what is this guy's minimum value? 0, right? So this is 1. But then it cannot ever reach 1, right? Yeah, it cannot ever reach 1, even though if, so it's not exactly on 2 because it does not include 1 in its range. Yeah. F increases for, I mean, okay, think if this was equal to 1, then this would be 0, and then you just have x squared plus 1 like approaching infinity, and that approaching thing, that's why it's not included. F increases for x bigger than, okay, so this was just 1 minus 2 upon x squared plus 1, right? So what is this thing, x bigger than 0, and decrease for x less than 0. Let's just think about what happens for x bigger than 0. When x increases in magnitude, this x squared plus 1 increases, so 2 upon x squared plus 1 decreases, so this function 1 minus 2 upon x squared plus 1, it increases. So yes, f increases for x bigger than 0, and it decreases for x less than 0. Cool. Minimum value is not attained even though f is bounded. I mean, the minimum value is attained, maximum value is not attained. The area included by the curve y equal to 5x in the line y equal to 1 is pi square units. Okay, and the line y equal to 1. This is always less than 1, we know that for sure. So it's like integration from 2 times integration from 0 to infinity of 2 upon x square plus 1, right? That's how much less this function is, dx, and I should be doing it. So included by the curve, okay, no, not 2 times, it's just single, because yeah, of course y equal to, wait, y equal to 1. Now, yeah, in fact, you know what, it should be 2 times. If you try to graph this, y equal to 1 would be something like this, and this function is always less than that. It starts off as, when you x is 0, this starts off as -1, and then starts to increase. It goes like that, boom. Over here too, it goes something like this. Cool. So what does this tell us? Well, I mean, like, it should be differentiable after all. So this doesn't make sense, because like it should be something like this, the curve should be like that. Anyway, you just want to find out what this complete area is. So it's the integration from negative infinity to infinity, or like, yeah, 2 times 0 to infinity of 2x upon 1 plus x squared, right? So it's natural log, okay, I should really just say this is like 2 from 0 to infinity, or 2 times. So natural log of 1 plus x squared, 2, and it's going from 0 to infinity. This would be 2 times, this was not good, the area would be infinite. Why should this be pi square root units? It is 2x upon 1 plus x squared. Sorry, it's 2 upon 1 plus x. Ah, right, of course. It's not 2x, so this is not the correct thing. So it is 4, and this thing is just tan inverse x from 0 to infinity. So 4 into pi by 2 minus 0. So it's just 2 pi. Wait, it's just 2 pi. Let's just check this once again. Of course, it's just 2 pi, not pi. Yeah, I guess that's correct. The line y equal to 1. Yes, next question. function y equal to f of x satisfies the differential equation dy upon dx sine x minus, okay, such that y approaches 0 as x approaches infinity, then the statement which is correct is fine. Let's solve this. So it's like derivative of, hey, that's sine x, well then that's not right. You took the derivative of y first of all, and then in the second part you should take the derivative of sine, which is not negative cosine, it should be positive cosine. So this is not like that, it's a linear difference, right? Minus y cot x plus sine x upon x squared equal to 0. So the integrating factor would be integration of negative cot x, but e to that, so cosec x, right? Cosec x, yeah, we know it's just going to be derivative of y cosec x. It should be equal to, okay, plus, so cosec x sine x is just 1, so 1 upon x squared equal to 0. Yeah, that's nice. So it's gonna be y cosec x plus equal to negative, yeah, it's just gonna be 1 upon x plus c, of course. So y equal to sine x upon x plus c sine x. Okay, and we have y approaches 0 as x approaches infinity. Yes, that's right. That's, wait, if it has to approach a particular value, then this thing must be 0, because if it's not 0, it's not defined, right? Its limit is not defined. So then it should just be this thing, sine x upon x. Then the statement which is correct is limit as x approaches 0 of f of x is 1. Yes, that's correct. Integration from 0 to pi upon 2. Hey, we already did this. We know it's less than pi upon 2. Wait, no, it's not less than, it's more than pi upon 2. Of course, it would be more than, wait, was this less than, something's not right. So integration of sine x upon x, it is less than if it was 1 dx over there. Yeah. Wait, yes, that's correct. That is in fact correct, of course. So yes, it's correct. This is bigger than 1. Well, let me show you. Integration of sine x upon x dx. This was when sine x equal to that. Okay, cool. And it's from 0 to pi upon 2, right? If I try to graph these two functions, that is, so sine x would look like this and x just looks like that. At pi by 2, this is 1 and this is, yeah, cool. So this would just be I mean, like the minimum value, that would be 2 by pi. Yeah, maximum value is 1. The minimum value of 2 of sine x, yeah, so it's going to be bigger than that. So it's definitely bigger than integration from 0 to pi upon 2 of 2 by pi dx, which is 1. So yes, it is greater than unity. It's an odd function. No, it's not an odd function. When you put negative over there, it just still turns out to be positive. Okay, next. Let dy by dx plus y equal to f of x, where y is a continuous function of x with okay, huh, okay, fine. So you just have e power x, we should say like d by dx of e power x y. This would be e power x f of x. Now let's think about what happens if yeah, f of x, right? So if it's from 0 to 2, what would happen in that case? Then it will just be 1. Okay, in fact, I'll just look at the options. So y of 1, y dash of 1, and y of 3, y dash of 1. Yeah, think about what happens at 0. At 0, of course, it's just 1. So yeah, just have e power x y equal to integration of e power x f of x dx, and it's from 0 to x. Now this, like, yeah, I should say e power t f of t dt, and it is from 0 to x. Well, in that case, this thing should also be from 0 to x. So they said that y of 0 is 1, so e power x y of x minus, when you put 0 over there, you just get 1 and 1's like 1. So e power x y equal to 1 plus integration from 0 to x e power t f of t dt, right? Yes, cool. So which of the following holds good? First, you want to find what is y of 1. For that, just put x equal to 1 inside this. Just e times y of 1, that is equal to 1 plus integration from 0 to 1 of this thing. Well, in 0 to 1, we know that this is e power negative x, right? E power negative t in this case. So it's just what was I saying? It's from 0 to 1, right? So it's just going to be 1. So it's 2. So y is 2 e power negative 1. Yes, that's correct. Y of 3. Y of 3. I mean, I really don't want this, but fine. And what's y dash of 3? So we know something about y dash. Like when you are talking about x being in 0 to 2, that is when x was 1, you would have this thing that e power x y equal to 1 plus, well, all the constants, they don't really matter, so you just have to take the derivative and stuff. Yeah, whatever. But still, integration from 0 to x, and in this case it was just 1 dt, so it was 1 plus x, right? So in that case, y was just 1 plus x upon e power x. Yeah, and the derivative of that thing, so y equal to e power x minus rate of the downside thing, okay, times x plus 1 upon e power x squared. So this would just be 1 minus x plus 1, which is minus x upon e power x. So for y of 1, you, yeah, like y dash of 1. So y dash of 1 was what was that thing? Y dash of 1 was, when you put this was the minus, yeah, that's how it is. So this is correct, y of 3 and y dash of 3. So for that, you would take that inside it. Okay, let's delete this. Okay, delete that as well. In fact, no, let's just say that it is 1 plus integration from, sorry, not 1, it's 2, and then it's from 2 to x something x, and in that case f was e power negative 2, so it's like e power t minus 2 dt. So e power x y equal to 1 plus, this is just 2 plus e power x minus 2 minus, when you put 2 over there, just get minus e power 0, which would be 1. So it's like minus 1, so it cancels. So this is, of course, it's just 2 plus e power x minus 2. Yeah, looks right. So that's e power x times y. So y equal to something like this. Okay, and then we just want to find what is f of, sorry, y of 3 and y dash of 3. Well, y of 3 would be 2 e power negative 3 plus e power negative 2, right? Yeah, but that's not in the options, so this is not like correct. Okay, and for y dash you would just have y dash equal to negative 2 e power negative x. So y dash of 3 would just be negative 2 e power negative 3, which is in the options. Cool. Next question. Tangents at any point p on the curve y equal to f of f of x y equal to 0 cuts the y-axis at t, the tangent. No point in drawing this, but yeah, it's like y minus y naught upon x minus x naught equal to m. Okay, and it cuts the y-axis, that means x is 0, so just this thing, that is t. Okay, so it's just y minus mx comma 0, that is t, where the point p is our x and y, right? If the distance of the point t from p equals the distance of t from the origin, well, distance from t from the origin is like y minus mx, that's the mod of that, and that is equal to the distance of t from p. Okay, so this thing, square root of, why are we even doing this? Oh, sorry, it should be the opposite thing. It should be like 0 comma y minus mx, because the y-intercept, right? Yes. So this would be x squared plus mx squared, like m squared x squared. Cool. So yeah, it would just be y squared plus m squared x squared minus 2xym equal to x squared plus m squared x squared. Some stuff cancels. Thank god it's not a degree 2 thing. So now this just becomes 2xym equal to y squared minus x squared. Cool, that's cool. So you just have m equal to y squared minus x squared upon 2xy. Hey, that's an homogeneous equation. Okay, fine, we're not doing anything there. Then the curve with this property represents a family of circles. Which of the following is or not correct? Fine, let's actually solve this then. So this is let's just put y equal to kx. So this will be k plus x k dash equal to k square minus 1 upon 2k. So x k dash is, it goes over there, so k squared minus 1 upon 2k minus k. I've seen this a lot, have I not? Yeah, so this is going to be minus k squared minus 1 upon 2k. So k dash times 2k, or did I write it like that? K dash 2k upon k squared plus 1 equal to negative 1 upon x. Yeah, doesn't that look correct? It's like negative 1. Yes, that looks correct. Cool. Now just integrate this thing. So it should be natural log of k squared plus 1 equal to negative natural log of x plus c. So it's just k squared plus 1 equal to something like cx, okay, ax, actually a upon x. Yeah, and k is just y squared upon x, so it's like y squared plus x squared equal to a times x. That's right, it's actually a family of circles. So y squared plus x squared minus ax equal to 0. Instead of having ax, I'll just say it's 2 small ax. So y squared plus x minus a squared equal to a squared. Cool. So it would be something like this. Yeah, any arbitrary line y equal to mx cuts every member of his family at points where slope of these members are equal. Yeah, of course, look at this point, the origin. Y equal to mx cuts it at this point where the slope is always, well, infinity. So yeah, is there any other? Okay, maybe they are talking about this point, like the slope of that. For that slope to be equal, what you actually want is that this angle should be constant. And when would this angle be constant? Okay, an arbitrary line equal to mx cuts this. Oh, so this angle is constant, we know that thing. Of course, look at this, the arc subtends this angle at the circumference and then double of that angle over here. So if theta is 2 theta, so yes, this line has a constant slope. So yeah, like the tangent has a constant slope. Yes, so this is correct, I guess, right? I guess so. And what would happen if we go in this direction? Well, then too, its slope is like that, and it's just symmetric, right? Yeah, this angle is theta, so then this angle is like fine, it happens. Okay, f of x equal to 0. Okay, so this thing, is orthogonal to the family of curve x squared plus y squared plus ky equal to 0 for all k belonging to real. I don't know about this thing, bro. Okay, what was the original equation that you had? Well, the original equation was very complicated, let's not deal with that. So why should this be orthogonal to this thing? Well, orthogonal circles, what property do they have? They have the property that the distance between the centers squared is like, this follows Pythagoras theorem, so the radii squared and stuff like that. Okay, so in this case the center is a comma 0 and the radii is a. In that case the center is k by 2 comma wait, actually not, it's 0 comma k by 2 and the radius is k, right? K by 2, yes, it's k by 2 squared, like, makes sense. So yeah, the radii 1 squared plus radii 2 squared is in fact like that, the distance between those. So yes, it does cut it orthogonally. F of x y equal to 0 passes through 2 comma 2, then the intercept made by its director circle on the y-axis is equal to 8. Okay, it's director circle, some circle that always has, okay, yeah, it should just be square root 2 times that. Okay, cool. So what are you saying, that if f of xy is passing through 2 comma 2, okay, let's just put 2 comma 2 was like, okay, cool. So 4 plus 4 minus 4a equal to sorry, so yeah, that's 4a, so a equal to 2, so y squared plus x minus 1 squared, wait, no, so x squared minus 4x equal to 0. Okay, intercept made by the director circle on the y-axis. Let's just draw this. This is the radius 2 over there, and the director circle has square root 2 radius like this, so it's going to be the same left hand side, but square root 2 times of that squares, like 8. The intercept made by the director circle like this. Okay, this distance is, well, we know its distance is just 2, this complete distance would be 8, and then we just are interested in finding out what this thing is. No, it's not 8, it's a square root of 8, so this is square root of 8. So then what would this be? It's going to be square root of 8 minus 4, which is 2, surprisingly. Yeah, I was not expecting this. Okay, cool. Maybe the director circle on the y-axis is equal to 8. It's not equal to 8. Okay, if f of xy equal to 0 passes through negative 1 comma 1, then the image of its center, wait, how does it pass through negative 1 comma 1? Okay, fine, whatever. Yeah, then the image of its center in the line y equal to x is 0. Just draw this. So it passes through negative 1 comma 1, so like this. So this thing should be its center, I guess. Okay, passes through, and then the image of its center in the line y equal to, this line is y equal to negative x. Okay, that's not the way. This would be line y equal to x. So its image of its center, of course. So this center is negative 1 comma 0. So that would just be like over here. So it's going to be 0 comma negative 1. What's the big deal with this? So the image of its center is not 1 comma 0. Next, consider the functions f of x and g of x both defined from real to real and are defined as, okay, if the area between f of x and g of x in the first quadrant is 1 by 2, then n is a divisor of, wow, okay, n belongs to natural numbers if the area in the first quadrant is 1 by 2. Then what is it really? What is this thing? Well, first of all, we know that n can only be 1 or 2, because if it was a cube, for example, then we know that cubes increase much more rapidly than squares do. So this area would basically just go to infinity. So yeah, area between f of x and g, it starts at 0, and this too starts at 0, right? This, oh wait, actually no, this is a, what's the derivative? This is 2 minus 2x, isn't it? Yeah, of course, it keeps on increasing till 1, and then it starts to go down like this, and y equal to x power n, like, okay, its slope is 2. Okay, cool. If n is like a cube or something, then that would not be good, because it's, I mean, okay, if n is anything, it doesn't matter, because its slope at the start is 0 and it increases. So we know the order. It's like this is going to be bigger than that, and that this area is basically what we are looking for. So just integration of 2x minus x squared minus x power n dx, and from somewhere to somewhere, but we have to solve for that somewhere thing, 0 to x naught, of course, and this should be equal to 1 by 2. Then n is a divisor of, what is this total area? It's kind of a question, like what's this total area? It goes from 0 to 2. So integration from 0 to 2 of 2x minus x squared, this would be x squared minus x cubed by 3 from 0 to 2, which would be 4 minus 8 upon 3, yeah, which would be 12 minus 8, which is 4 upon 3. So 4 upon 3 is this total area. When does this intersect that? It only intersects once, but where? Like x power n plus x squared x power, it could even be something like a line, yeah, it will just be y equal to x. Well, no, it cannot be a line. If it was a line, then yeah, in fact, even if it was a line, it would still work, because this slope is just too much, it's very big, so it would cut it like that. So really n belongs to natural numbers. Okay, then n is a divisor of, oh god, okay, let's still try to do this. This would just be x squared minus x cubed by 3. Wait, not from 0 to from x not, okay, cool. Minus x power n upon n plus 1, right? Okay, and when you put 0 over there, it becomes 0. This is equal to 1 upon 2. This should have a solution such that that equation is also followed, which was x power n equal to 2x minus x squared. So these are like a system of equations now. So that's nice. So you can just put this into that, I guess, like x squared minus x cubed upon 3. But then what about this n plus 1? This is gonna be not good. Okay, so now what do we do? You cannot find direct solutions of this thing. You cannot do anything. How am I supposed to solve this? Like 3x squared minus x cubed minus 3x power n upon n plus 1. But it's no use. What the heck? 1 by 2. Wait a second. Okay, let's resume. It's 1 by 2, huh? What is this value or this, like, it was when you put x equal to 1, you just get 1, so this would be 1 over there. Okay, so this is very geometric, right? Huh, it's x power n, so hey, that is it, x power n, right? So it does intersect every single time at this point. Of course, when you put x equal to 1, it just becomes 1. So yeah, that's very nice. In fact, this could be written like x power n minus 1 equal to 2 minus x. 1 is an obvious solution, and considering the fact that this is actually just increasing, this will be the only solution for us right now. So it's just the integration from 0 to 1 of that thing. So all this stuff is just having 1 over there, like 1 minus 1/3 minus 1 upon n plus 1 equal to 1 by 2. Hey, we can just find n itself. So this would be 2 by 3. So just have 1 upon n plus 1 equal to 2 by 3 minus 1 by 2, which would be 1 upon 6. So n plus 1 equal to 6, n equal to 5. Cool. And what are the same? N is a divisor of, it's the divisor of 15, 20, 30. Next question. Let C be a family of curves. Yes, I believe that's correct. Let C be a family of curves. The number of C is x-axis. How much is remaining, bro? It's almost done. Let's just keep going. Okay. Let C be a family of curves. F of x, y, C equal to, wait, what? C. What is this thing? It's a constant, maybe. Okay, cool. No member of C is x-axis, such that the length of subnormal at any point P x y on the curve C. Subnormal. What was subnormal? These definitions. Like if you have this function, the tangent is this thing. This is the normal, and I guess this was the subnormal, and this was the subtangent. Okay, cool. Okay, so what are they saying? Let's see the family of curves such that the length of the subnormal at any point on the curve C is equal to 4 times the length of the subtangent at the same point. Okay, which one of the following statements are correct? This is bad. Right, let's just think about it. This is our sum length y. Okay, we know that, like, this is our normal and this is our tangent, for example. So this has slope m, this is slope of minus 1 upon m. So if this angle is theta, say, then this angle would be theta, and this angle would be 90 minus theta, and then this angle will be theta. So this angle will be 90 minus theta and this angle will be theta. So you just have y cot theta is what is this? Is like this was our tangent, right? This was subtangent. It's subtangent, and y tan theta is the subnormal. Okay, and what they said is that subnormal is 4 times subtangent. So tan theta upon cot theta, or tan theta is like really just m. So m upon 1 upon m is 4. So m squared equal to 4. Cool. Okay, and this is at any point. Wow, that's something. So like m is 2 or minus 2. That's weird, because what that means is like the slope is a constant. Of course, that's all it could mean, really. So yeah, slope is constant. Okay, then which of the following statements is or are correct? The equation of the line with positive y-intercept passing through 4, 2 and perpendicular to the curve C is okay. So like subtangent. The following statements are correct. It could be something like whatever. Just put this y equal to 2x plus c, or y equal to minus 2x plus c. That's the only thing it could be. Equation of the line with positive y-intercept passing through 4, 2 and perpendicular to curve C is y plus 2x equal to positive y-intercept. That means the curve has, the C thing has negative intercepts. No, like y-intercept it's different altogether. Y-intercept could be anything, right? Yeah, passing through 4, 2 and perpendicular to, yeah, so it's either 1 by 2 or it's negative 1 by 2. It's 4, 2, then just putting 1 by 2 you would get a negative intercept. When you put the slope as minus 1 upon 2 you would get a positive intercept, I guess. Yeah, cool. What happens when you put the intercept as 1 upon 2 though? Oh, then this would just pass to the origin, because yes, positive y-intercept, then this should be this thing. So yeah, just y minus 2 upon x minus 4 equal to negative 1 upon 2. 2y minus 4 equal to minus x plus 4. So x plus 2y equal to 8. Yes, that's correct. Orthogonal trajectory of C is family of parallel lines having gradient plus or minus 2. No, having gradient plus or minus 1 by 2, that should be the thing. Order and degree of the differential equation of a family of curves are 1 and 2 respectively. Not really. I mean, no, not quite. Just have m squared equal to 4. Wait a second. Yeah, in fact, yes, I was thinking about like linear equation stuff, so that's not correct. So in fact it is correct, because m squared equal to 4, that represents the whole thing. Differential equation of the family of curve is, nope, it's not the differential equation at all. Next, of course, next, the function y equal to 4 e power 4x plus 2 e power minus x is the solution of the differential equation. Shit. Then the value of k by 3 is, okay, Fine, let's just put that inside it and let's just see what happens. So y equal to e power 4x plus. Oh, it's 2 over there. Okay, so 2, 2, 2, and 2. Here 2, 2, 2. And let's solve. So 64 minus 13 times 4, which would be 4 and 12, 52, I guess. Yes, e power 4x. So yeah, and y double dash is negative, y dash also has negative. So this will just be 1 minus 13, which is negative 12 times negative 2 is 24. So plus 24 e power negative x upon all that stuff. So this would just be 2, 1, huh? Yeah, of course. Power 4x plus 2 e power negative x. This thing is just 12. So this complete thing just turns out to be 12. So k is 12. K upon 3 is 4. So this is q. Number of straight lines which satisfy the differential equation. Okay. This is not good. Straight lines, huh? So y equal to mx plus c. If that's our straight line, then we just have y dash equal to m, and then y double dash equal to 0. So you just have m plus x minus y equal to 0. Yeah, for all values of x and y, which just means y equal to x plus m. But that's the thing, right? It's like in this case m is 1, so y is x plus 1. There's only one line that satisfies this thing. Yeah, that's right. There's only one line that does. Wait a second, but shouldn't it be having zeros and okay, wait. First of all, d square y. Oh, it's dy by dx squared, of course. So yeah, y is just m squared x plus m. That's weird. So just have m. Yeah, it's like dy by dx is m, but at the same time it's also m squared. So m squared is equal to m. So m equal to 1 or m equal to 0. So you just have y equal to 0 or y equal to x plus 1. That's the only thing. So it's two lines. If real values of m for which the substitution y equal to u power m will transform this differential equation into a homogeneous equation, then the value of 2m is oh, okay. Will transform the differential equation into homogeneous. Wait, what? This statement looks incomplete. It starts with if real value of m for which the substitution will transform this differential equation into a homogeneous equation, then the value of 2m is, oh, so if the value of m is such that they didn't write everything. Okay, just put y equal to u power m, right? So 2x power 4 u power m, and this would just be times m u power m minus 1 du, right? Yeah, du upon dx, I guess. Okay, cool. Plus y power 4, so u power 4m equal to 4x power 6. So simplifying this, get 2m x power 4 u power 2m minus 1 du by dx plus u power 4m equal to 4x power 6, like 4x power 6 minus u power 4m, of course. So you just want 4 plus 2m minus 1 to be equal to 6, and it should also be equal to 4m at the same time. So 2m equal to 3 over here, and yeah, that also gives like 2m equal to 3. So in fact m equal to 3 by 2 is the thing. So value of 2m is 3 as we got over there. So p, cool. If the solution of the differential equation is of this differential equation is this thing, then m plus n is these are like, just put this inside that and get the value. Of course, that's all there is. But I want to do it some other way. Think about it. Look at x squared, its derivative is 2x, and dy by dx, its derivative is t squared. Isn't it just dy by dx of x squared dy by dx equal to 12y, right? Of course, it's just that. So x squared dy by dx that should just be equal to 12y plus some constant. No, it's equal, of course. Wait, but that's a y over the, no, not good. This is not good. It should have been y over there. That's not the thing. Equal to 12y. That's not a good differential equation at all. Yeah, whatever. Let's look at this thing then. Okay. Y equal to a x power m plus b x power negative n. Okay. So y dash would be equal to m a x power m minus 1 minus n b x power negative 1. So y double dash equal to m into m minus 1 a plus n into n minus 1 b. Okay, it's obviously that thing over there as well. Shit. X power m minus 1. Okay, this guy, and x power negative n negative 2. Oh, this should also be like m minus 2 over there. M minus 2. But in doing so, what you are actually assuming is that y is some kind of polynomial function, isn't it? But how did you get that it's a polynomial function out of nowhere? Yes. This is a polynomial. Oh, so negative n is not actually a polynomial. Okay, fine. Yeah, let's do this. So I'm going to put this inside. That's like x squared. It's just going to be m into m minus 1 times a x to power m plus n into n minus 1 b x power negative n. Okay, plus 2x dy by dx. So yeah, plus 2 times m into a x power m minus n into b x power negative n equal to 12y. So equal to 12 times a x power m plus b x power minus n. Fine. So you just have this thing that m into m minus 1 plus 2m equal to 12, and n into n minus 1. Yeah, oh no, it should be n plus 1 over there, because when you did that it became n plus 1. Minus n, so minus 2n equal to 12. These are the equations. Cool. Let's just solve them. So like m squared plus m minus 12 equal to 0, right? Of course it's like m plus 4 into m minus 3 equal to 0. So m is 3 or m is minus 4. That's the thing. Okay. And for n, okay, so what's like mod of m plus n? And if you're going to get two solutions all the time, then this might become very problematic. What if, like, yeah, what if we didn't in fact have that in the first? This could be so complicated. I mean, there are so many possibilities for this to happen, and it could also be that one of these like just becomes 0 in the second derivative, or even in the first derivative itself. Well, okay, if it becomes 0, then it will show in the formula itself. It's not to be feared. Yeah. So yeah, in that case, let's just keep going. And this other equation gives n squared minus n minus 12 equal to 0. So n is 4 or n is minus 3. So then m plus n, it's either 3 plus minus 3, that would just be 0, or it's like 4 plus minus 4, something like that. Wow. It could be any of these things. Like it could be starting from like it could be 7 maximum, minus 7. It could be 3 and minus 3, which would be 0. It could also be that thing, it's like that's also 0. And it could also be, well, minus 4 minus 3, we already did that. So yeah, it can only be one of these things. That's weird. So none of these have that other thing. Okay, so it's one of these, so it could be 0 in that case. So it's not anything that looks correct. Now what? It's not 1 anyhow. Yeah, best just leave this. Okay, fine. So this is all that there was. Okay, let's just check everything. So we start from fourth question, D. 7B, 8th A, 9th AC. Yeah, that's right. 10th ABC. That is weird. I mean, why is this homogeneous function of degree 0? Doesn't make sense. Okay, this is weird. Yeah, it's like whatever. 11th ACD. No, but like, oh, which does not hold good. Okay, fine, that's why it was. Okay, so this is wrong, even though I solved it very correctly. So this is incorrect and these other options are correct. 12th ABC, that's correct. 13th ABD. 14th AB, yeah. BCD, that's correct. 17th AQ, that's right. BR, that's also right. And C p, and ds, I don't know about that. That was it. All right, I'll see you later.